morning, everybody. So we are here to practice the June 2025 Earth and Space Science exam. And so here we go. Okay, so this is the front cover of the exam. We're going to open it up. And for number 1, our sun, a star. So they tell us that the HR diagram was developed by 2 scientists. I'm not going to read the whole thing through, but they tell us that absolute magnitude is a measurement of how bright a star would be if all stars appear at the same distance from the Earth. Okay, so then number 1 says our sun is classified as a general class G star with a surface temperature of about 5,000 to 6,000 and an absolute magnitude of about 5. Based on this information, complete the HR diagram model by placing 1x where the sun is located. Also, identify the relative temperature and relative absolute magnitude of the sun as it transitions into a red giant. So just making sure that you can see. All right, and so if you look at the HR diagram, if we want to place at X on a chart where the sun is located, well, first thing we have to know is what kind of star is the sun. Is it a giant, is it a supergiant, white dwarf, or a main sequence? So if you are not sure about this, if your knowledge for stars is just not there, you can come to your reference tables and you can find the sun. Okay, so here we see the sun. And so we see that it's on the main sequence line. So I know that I can go back to my diagram, I can find the term main sequence and just make an X right there. All right, so that is how I'm going to answer this one. So as you can see, my X lays right there next to the main sequence. All right, if I want to write how the temperature changes, so they tell us that the temperature for the star was about 5,000 to 6,000 as a main sequence, right? But then if I change the temperature and I go to a red giants are only about 3,000 in temperatures, and I go up, then I'm going to be able to see that my temperatures are going to decrease. All right, so decreases or gets lower. All right, and then if I want to look at the absolute magnitude of it, I can see that absolute magnitude, as you go up, they become negative numbers, right? So since they're negative, we know that our absolute magnitude is going to also decrease. All right, number 2. All right, so they give us a sun layers diagram, and it tells us that each layer of the sun basically is different features of different layers of the sun. All right, so if we base our information on that model that they give us, which list of the 5 sun's layers are in correct sequence to allow energy generated by the fusion to eventually reach the sun's surface as radiation? All right, so if we want to eventually reach the surface as radiation, what is the order? Well, if you look at the picture that they give you, the diagram, and you know that everything starts in the core, right? So the first thing we see, everything starts in the core for our answer choices. All right, but what happens next? So we know that energy needs to be created, right? Or energy will be created in the cores. So the first thing I see where energy is created in the core diffuses slowly through plasma is the radiative zone. So that is going to be my second arrow. So I can see choice 2 and 3 is going to be my best choices. So what happens next? Of course, that heat has to be, of course, cooled eventually or transported. So we have our convection zone where we know that convection currents will transfer heat. All right, and then last, as we can see, if we look at the diagram on the other side, that the chromosphere is outside of the photosphere. So our next layer should be photosphere and then chromosphere. Which answer choice shows that order? Number 4. All right, question number 3. All right, so question number 3, as you can see, they give us a model of the Earth and the planets orbiting around. Okay, so then the question is going to read, the table below shows the eccentricity of the orbits of Mercury and Venus around the sun. Mercury has an eccentricity of 0.206, my Venus 0.007. So they want us to place a check mark in 2 boxes with the correct statement. So only 2 choices out of the 5. So is Venus orbit around the sun at a constant speed? Well, we know anything about Venus. We know that Venus is like the second planet from the sun, so it's going to orbit fast, but no planets orbit at a constant speed because they switch back and forth between closer to the sun and further from the sun as they orbit. All right, so number one is not a good choice, but how about number two? Mercury travels faster in its orbit when it's closer to the sun. So yes, Mercury does travel faster when it's closer to the sun. Any planet closest to the sun will travel faster. All right, last one. Venus orbit is less elliptical than Mercury's orbit. So Venus orbit is 0.07, which is closer to the number 0, right? So I know that this is going to be more of a circle shape because remember, 0 equals a circle. 1 equals an oval. 0 circle, 1 oval. Please remember that for yourself. 0 circle, 1 oval. So if I'm 0 circle, I'm less elliptical. But if I am more of an oval shape, I'm more elliptical, okay? I have more eccentricity. So with that being said, Mercury orbit is less than that of Mercury's. Venus orbit is less than that of Mercury's. All right, so I already have 2 answer choices, so I'm not even going to read the rest. Okay, number 4. It says, based on a solar system model, if a new planet was identified that orbited the sun at an average distance greater than Mercury, so I'm greater than Mercury distance, but less than Venus. So if you are looking at the solar system data chart, you can see that Mercury and Venus are the 2 planets right in order, right? So that means that this planet is going to sit right in the middle of those 2, basically. So if it's sitting right in the middle, and we know that Mercury is going to spin the fastest, then that means we know that it's going to have a less average speed than Mercury. So let's see. One of our answer choices that says it has less average speed than Mercury is going to be answer choice 2. So less average than speed than Mercury, but greater than Venus because it's in the middle of Mercury and Venus. All right, so answer choice number 2 would be best. Okay, question number 5. An observer on Earth sees phases of the moon, but the moon isn't the only solar system body that exhibit phases. Venus also has observable phases as viewed from Earth. Venus is approximately 225 Earth days away from the sun. All right, so they give us this little Venus and moon diagram, and then they ask us, using the solar system model, construct an explanation for why an observer on Earth can see a cycle of phases for the planet Venus. In the spaces below, write the term for choices A, B, and C that correctly completes the passage. All right, so Venus orbits around the sun circling what? Does it circle on the inside or does it circle on the outside? So go back to your diagram, and looking at the diagram, we see that the sun is in the center. So if the sun is in the center, do they orbit on the inside or the outside? They're going to orbit in the inside. Okay, inside is your choice. Because they're inside of Earth's orbit, okay? All right, and then next one is, this means that Venus is sometimes blank Earth, while other times it is positioned on the other side. So if it's positioned on the other side further from, that means that choice B has to be closer to, right? And then C says positioned on the other side of what? Well, what are we talking about? What is it circling around? What is it orbiting around? The sun, right? We're not talking about the moon, right? We're talking about the sun. All right, so that is it for number 5. Just making sure that you've seen that. And of course, if you're watching this review, I should hope that you have the exam right in front of you. All right, so this is the next one. And they tell us that they're modeling Earth systems to understand global climate. All right, so the geologic rock record, it shows a long history of climate fluctuations as many different factors, as a result of many different factors. And then they told us that obliquity is the tilt of the Earth's axis relative to the sun and has a direct impact on Earth's climate. The obliquity changes cycle over a period of 41,000 years. The obliquity is currently decreasing, which will reach its maximum value of 22.1 degrees. All right, so that was a lot they said, right? Turn it over, and the question says, during winter, which statement describes the amount of energy Earth's northern hemisphere will receive and the impact on global ice formation when the obliquity is 22.1 degrees compared to Earth's obliquity? So 22.1 degrees is what they said it's going to become But right now we know that Earth is 23.5 degrees in obliquity, right? So if I change it from 23.5 degrees to 22.1 degrees, I can expect to receive some more of that sun's direct rays, right? So I'm going to have more energy that's going to come down. And when I have more energy, well, what do I think is going to happen? Of course, the polar regions will melt. So our answer choice for number 6 should be 4. All right. All right, let's move on. So as we can see, we had started the second cluster at number 6. So don't forget that these questions are cluster questions. So number 6 is part of the second cluster, which goes from 6 to number 10. All right, so this is the second cluster question in this one cluster. And it says, which statement accurately describes the influence of melting glaciers at X on the strength of Earth's ocean currents? All right, so they give us this diagram. As we can see, it's quite a few things going on here. So what effect does our ocean currents have? We know that it's going to transport warm or cold water, right? So it says, what effect does it have at Y? Melting glaciers at X. So we can see that they all say that we're going to add more water, right? Because we see that more fresh water is being added. It tells us that in the diagram. So since more fresh water is being added, does this cause the currents to deepen, weaken, become more dense, or become warmer? So let's see. We have no evidence on here that says that they become deeper, besides this warm current shallow inside of this one diagram. But that does not give me evidence that X will become deeper. Okay, so what about answer choice number 2 told us that more fresh water will be added, causing things to weaken. So can we see in the diagram, it says that in diagram 2, the influence of fresh water, that number 1, we had an increase in glacial ice, and then at 2, we had additional fresh water with salt and lower density. So we know it doesn't get higher in density, it doesn't get denser, it gets lower, right? So then the warm water can't move. Why can't it move? Because what? The weaker currents, correct. So weaker currents, that means that we will have more fresh water added, but a weaker current. We know that they don't become dense, we just seen that. And then we don't know if they will become warmer or cooler. I think it's going to depend on the ocean current. All right. Number 8. Which statement most accurately describes the influence of present surface ocean currents on the climate at Y? Okay, so here's Y, and we see, according to the map key, that Y is a warm current. All right, so what does it says? Location Y experiences warmer air temperatures and more precipitation. Location Y experiences warmer air temperatures and less precipitation, or cooler temperatures and less precipitation, or more. So since we know Y is a warm current, we're automatically going to say warm for our answer choices. So answer choice 1 or 2. And will I have more precipitation or less precipitation? Well, think about it. Warm air rises, right? Condenses and cools, and it causes some type of precipitation. So I should automatically know. I don't even have to go back to the diagrams to know that I should receive more precipitation if I have warm air temperatures. All right, number 9. Okay, so number 9 is showing us that the sun is being reflected and absorbed depending on if you have a light surface or a dark surface. They give us this diagram and show us how much ice have been lost over the years. All right, then they want us to correctly say which model is going to represent the feedback that occurs when dark surfaces are exposed in glacial areas. Okay, so I want you to recognize first when you start this that your answer choices for boxes, all the boxes going down for answer choices 1 and 2 are the same. The only thing that changes is when you get to the end, and that is if the glaciers will melt or if I will have decreased or increased ice. So if I have a dark surface, I automatically should know that I get more absorption, more energy absorbed, right? What happens when you get more energy absorbed? You will get increased glacial melt, right? But when you get increased glacial melt, do you get decrease of ice or increased ice? Of course, a decrease of ice. So our best choice would be number 4. All right, so 9 is 4. All right. So I'm going to do number 10 in this last cluster, and then I will come back to you guys at a later time. Okay, sorry about that. A little disruption. Okay, so they give us this projected atmospheric greenhouse gas concentrations for scenario A, B, and C. All right, same here. Global surface air temperature changes from the greenhouse gases. Scenarios A, B, and C again. It tells me to identify the numerical values for the projected concentrations of greenhouse gases, CO2 equivalent, for the approximate future change to global surface temperatures during 2100 using scenario B. All right, so scenario B, right? You will have a ruler at the exam. If you don't have a ruler or want to use a ruler, my suggestion is to make you a really nice dotted line and try to get that accuracy. So my dotted line is telling me that my answer choice should be about 2.4 because it doesn't reach that 2.5 line yet, okay? All right, so since it doesn't reach the 2.5 line yet, then I know that for the temperature change, I could put 2.4. Okay, and then how about the scenario B for the CO2 ppm? All right, I come here, scenario B, again, make a dotted line, and I should notice already that it does not all the way touch the 800 line. And so we can use a range. We can say something from like 795 to 800 for accuracy. All right, so 795 to 800 is what I'm going to use. And that is it for cluster number 1 and 2. Questions number 1 through 10 in our June 2025 Earth and Space Science exam. And I will be back with you guys to do questions 11 through 50 soon. Have a good day.